Hello and welcome back to the 5.4 notes. This is the last video for the fundamental theorem of calculus. And these are some practice problems using part one. And so we want to, we have these integral functions and we're being asked to take the derivative of these integral functions. So the first thing I want to do, let's go back and let's rewrite what the fundamental theorems are, okay? Let's recall that if I have some function, say big f of x, that is an integral defined function, so the integral, say, from 0 to x of f of t dt, okay? Basically what that means is that if I wanted to find big F prime of x, if I wanted to take the derivative of my integral function, then I would do ddx of the integral from 0 to x of f of t dt, and that would just simply give me little f of x. So that's going to give me my integrand in terms of my upper bound. Okay, the other one that we know is that if we want to evaluate an integral, say from a to b of, say, little f of x dx, then that's just going to be big F of b minus big F of a. Okay, so we have those two things. And what I want to do here, I know that in this example, I use this notation of big F of x to show what my integral defined function is, and I have little f. And what I want to do is, consider that over here with g, okay? It's just named differently, okay? I'm just using a g instead of an f, okay? So I'm going to rewrite this a little bit differently. I'm going to say here that g of x, okay, for both these examples, is equal to the integral from 0 to x of, and I'm just going to call this function right here f of t, okay? So f of t, all right, dt. And what I'm going to do is, if I were to take the derivative of this function g prime of x, then that's just going to give me my integrand in terms of my upper bound, okay? So I'm just going to write g prime of x is equal to f of x. Okay, so that same thing is going on. What I want to show you guys is that this idea here and saying this idea, okay, having an integral defined function and taking its derivative in this notation using big F of x is the same thing over here using the function g, okay? If I take its derivative, I'm still just going to get my integrand in terms of my upper bound. So I'll just get f of x, okay? So it's really not too terrible. If I wanted to find the derivative of my function g of x, okay, g prime of x, then I'm going to take the derivative of my integral function from 0 to x of sine squared t dt. Okay, and remember in the other video that if I take the derivative of my integral, okay, I'm just going to get my integrand in terms of my upper bound. This kind of just undoes the integral. So g prime of x is equal to just sine squared of x. And that's it, okay? So it's really not too terrible, but we do need to practice this and do a couple practice problems, okay? Let's go to the next one. Same thing, okay? I'm going to use this notion here. I have an integral defined function g of some function, say f of t dt, and if I take its derivative, then I just get the integrand in terms of my upper bound, okay? So what I have here is if I took g prime of x, if I took the derivative with respect to x of my integral from 0 to x of t squared plus 1 dt, then g prime of x is simply just going to be x squared plus 1, okay? And that's it, all right? So here's the thing. Let's take a look at this next one. Now, this is a little bit different, okay? Because, it's asking me just to take the derivative of this integral, but I don't have an x here, okay? I have another function. I have a function, the cosine function, okay? I still have my function f down here. And so what I want to do is that we're going to do the same thing, okay, as we did before. But if we have our upper bound as a function, then we have to evaluate this derivative a little bit differently, okay? So we are going to have to use the chain rule here. That's kind of the main idea. And so we're going to do something similar to what we had already done before. We're going to apply the fundamental theorem part 2, okay, to this, just so I can show you guys what we do. And by the fundamental theorem part 2, I mean this, okay? We're just going to evaluate this integral. So if I come in here and if I take, I'm going to rewrite this as d dx, okay? We're still taking the derivative of this, but I'm going to evaluate this part using the fundamental theorem, okay? I'm going to do part 1 on that. So I am going to do this. I'm going to put this in big brackets here, and I'm going to evaluate this integral. And that integral would be t to the 5th divided by 5, okay, plus 6t. Okay, I'm taking my antiderivative, and then I'm going to plug in 0 and cosine, okay? So then, all right, I'm going to draw my little line. I'm going to plug in 0, and I'm going to plug in cosine of x, okay? And I'm still just going to take the derivative of this whole thing. So now, all right, let's go ahead and apply that. So d dx of this whole thing is going to end up being, and I'm going to write it like this. I'm going to write 1/5. I'm going to bring that up front. Times, and you know, I need to plug in my cosine function in for t, okay? So I'm going to do cosine of x, okay, quantity raised to the 5th power, plus 6 times cosine of x, okay? And then let me do, okay, I've got that whole thing, okay, and then minus the whole quantity of plugging in 0, okay, into my function. So I've got 0 to the 5th over 5 plus 6 times 0, and then I'm going to close that up, okay. So now what I have is I get this derivative, okay, I get d dx of this function here. All right, and this part just goes to 0. Okay, so I don't need to write that. But I've got 1/5 cosine of x raised to the 5th plus 6 cosine of x. Okay, and so if I take the derivative of this function now with respect to x, then I have to use the chain rule. Okay, and I'm going to end up getting this. I'm going to end up getting 5 times 1/5 times cosine of x, this whole thing raised to the 4th power. But remember, I have to multiply by the derivative of my inside function, which of cosine, the derivative of that is negative sine of x. So I need to use the chain rule here if I'm taking this derivative, okay? And then I've just got plus 6 times negative sine of x. The derivative of cosine is just negative sine. Okay, so this is my derivative. Now I'm going to do a little bit of simplification here. I can divide out my 5s, okay, and then you know, the next thing I get is I get cosine of x, okay, raised to the 4th power, times negative sine of x. Okay, and then plus 6 times negative sine of x, okay? And when I have that, okay, all I get here is I get, and I'm going to bring this up here, okay? I can factor out a negative sine of x, okay? And I can then multiply that whole thing by, you know, cosine of x, this whole thing raised to the 4th power, and then plus 6, okay? So here's the interesting thing about this problem, okay? I'm not just plugging in cosine in for t, okay? I am doing that over here, but because I'm raising this to a power, or raising this to a function, not raising, I'm sorry, my upper bound is a function, okay, I have to then multiply by the derivative of my upper bound. Okay, so this is a little bit tricky to do, but that's all I'm doing is I'm just going to plug in my upper bound in for t if it's a function, and then I have to multiply by the derivative of my upper bound. Okay, and I'm going to do the same thing down here. Okay, I'm not going to go through all this same work, okay, that I did here, but I do want to do this problem. And so if I take the derivative of this, and let me rewrite this as d dx of the integral from, say, 0 to x squared of 1 over t squared plus 4 dt. Okay, this is one of those, if you see the dt up here in the numerator of this integrand, you can just move it out here and put the 1. That's going to help me do this. So then here's my my derivative, okay, of this integral function. It's going to be 1 over the quantity, x squared, quantity squared, plus 4, but then I'm taking this whole function and I'm multiplying it by the derivative of my upper bound, which is just 2x. Okay, and you could simplify this and you could say that this is 2x over x to the 4th plus 4. That would work too. This is probably what you'd see in the back of the book. But this is the idea. Okay, so if your upper bound is a function, then when you take the derivative, you have to multiply by the derivative of that upper bound and use the chain rule. So that's all I've got for this section. I hope you enjoyed this stuff. It is a lot of fun to do. Please get started on the homework, and we'll see you soon. Thanks. Bye.